You know that dream of an AI assistant? One that doesn't just find information for you, but actually does things. Books your flights, manages your projects, just handles all those tedious online tasks with a single command? Well, that's the big promise of autonomous AI agents. But if you've had this nagging feeling that the AI we have today isn't quite there yet, well, you're absolutely right. Let's get into why.
Here's the tough reality. When you take our absolute best, most advanced AI models and set them loose on the real, messy, chaotic internet, they fail. A lot. In fact, a huge study from Carnegie Mellon University found that even the top models fail at a pretty shocking rate. That's the big question we're digging into today. Why this 85% failure rate?
And I mean, just look at this difference. It is just stark. GPT-4, right, one of the smartest AIs on the planet, succeeds less than 15% of the time. Now compare that to your average person who gets it right over 78% of the time. It's not even a competition. This isn't just a gap, it's a massive canyon.
So what is going on here? Well, these numbers come from a major research paper that set out to give AI assistants a real, honest-to-goodness report card. And the results? They were pretty shocking. To really understand why the grades were so low, we've got to first look at how these AIs have been trained up to this point.
Okay, so the heart of the problem is something we can call the playground issue. See, for years, AIs have been learning how to use the web with training wheels on. They've been stuck inside these simple, predictable, and, let's be honest, totally unrealistic digital playgrounds. And the moment those training wheels come off, they just fall over.
Think of it like this. Training an AI in those old test worlds is like teaching someone to drive in a completely empty parking lot. Yeah, sure, they can learn to turn the wheel and hit the brakes, but it's totally predictable. The real internet, though, that's like throwing them into rush hour traffic in New York City. It's dynamic, it's chaotic, and it is completely unpredictable. You just can't prepare for that in an empty parking lot.
And hey, don't just take my word for it. The researchers behind this study said it perfectly. There's been this huge disconnect between the sterile, clean labs where AIs learn and the messy, real world where we expect them to work. So to fix this, they knew they had to build a much, much better test. And that is where Web Arena comes in. You can think of it as the ultimate final exam for AI. It's a testing ground built from scratch to be as realistic, as complex, and as challenging as the internet that you and I use every single day.
Now, this is super important. Web Arena isn't the live internet, it's a perfect self-contained replica. This means it has all the fully functional websites, but it's also reproducible. So every single AI can take the exact same test under the exact same conditions. And that, is absolutely critical for a fair fight.
And we're not just talking about one fake website. Nope. Web Arena is an entire ecosystem. It's got e-commerce sites, forums that look and act just like Reddit, developer platforms like GitLab, and a bunch of other tools like maps and calculators. It's all designed to mirror the crazy variety of things we all do online.
And the tasks they designed? Whoa, they are incredibly complex. They're called long-horizon tasks, which is really just a fancy way of saying they are multi-step goals that require a whole lot of planning and adapting. I mean, check this out. An AI first has to do research on Wikipedia, then it has to switch over to a completely different map tool for planning, and then it has to switch again to a developer site like GitLab to log the results. That takes memory, planning, and juggling totally different contexts. Just like a person would have to. All right, so now that we get just how brutally difficult this test is, let's circle back to that report card. How in the world did the researchers actually grade these AIs, and why were the scores so low?
Okay, this is probably the most important part of the whole thing. It's a concept they call functional correctness. Basically, the AI doesn't get points for just clicking the right buttons or trying really hard. It only gets a passing grade if it achieves the actual final goal. There are absolutely no points for effort.
So here's what that looks like. If the task is to post on a forum, a program automatically goes and checks, does that post actually exist? Is it on the right page with the exact right text? Or, if the task is to find a customer in a database, the system checks if the AI's answer matches the real record perfectly. It's totally binary. It's either a pass or it's a fail. So, after being put through this incredibly realistic and super strictly graded exam, what was the final success rate for the best agent out there, the one running on GPT-4? This, just over 14%. I mean, just let that number sink in for a second.
And when we put that number back on our original chart, the whole story becomes crystal clear. Even with all the amazing progress we've made, there is still this monumental gap between what our best AI can do and what an average person just does, without even thinking about it.
So the final, crucial question is, why? What's the ghost in the machine here? The researchers dug through thousands of failed attempts to find the patterns, to figure out what causes these powerful models to just fall flat on their face so consistently.
They found 4 main culprits. First, just poor judgment. The AI would constantly just give up, marking over half of the tasks that were totally doable as impossible. It just lacks common sense. Second, it was wildly inconsistent. It might nail a task one minute and then fail on a nearly identical one the next. It's not really reasoning its way through. Third, and this is a big one, a complete inability to self-correct. If you or I make a typo, we hit backspace, we know what the goal is. The AI, one tiny error can send it into a loop it can't escape from. And finally, this really weird thing they called observation blindness. The AI would literally ignore critical info that was right there on the screen, like text it had just typed itself. Its attention just isn't the same as our sight.
So, in the end, the researchers' conclusion is basically a call to action. They say flat out that even our best models are far from perfect, and that these results are proof that we need to be focused on building more robust, more resilient, and frankly, just smarter AI agents. Web Arena isn't just a tough report card, it's the new training ground to actually make that happen.
Ultimately, what this all shows is that building that dream AI assistant is so much harder than it looks. It takes more than just being able to click buttons. It takes real judgment, resilience, and a true understanding of our messy, dynamic world. So this research forces us to ask a much bigger question. It's not just about technology anymore, it's about trust. When can we really, truly hand over the keys to our digital lives?